Well, hi, good morning, and thank you so much for joining me in my shop here. Today is July 28th. The forecast for today is very hot, 34 degrees. Feeling more like 44 or something like that. And I got a late start here this morning, but I have some good news. The good news is I found this guy. So this is a tube extender. You just plug it in the tube socket and plug the tube in here, and it just raises the tube up that high and provides a bunch of contact points here where you can take your test probe and read voltages on the tube. This is a great thing for this radio. I have been prevented from checking a couple of very important basic things because of the construction of this radio. So you see how they've got a metal box here, and inside it is some tuner parts, capacitors, resistors, stuff like that. Up on top are two tubes. Where's the tube socket is right here. You can't get at it from underneath. Inside this box is the tumbler. Right, so to get at the parts at the top, you must remove the tumbler. Goodness knows the radio doesn't work at that point. So this is a tricky radio. If there's problems up inside here, accessing them, testing them, very, very difficult, including the tubes. So if I wanted to read the voltages that are being applied to this tube, I either have to get on the socket, which is not, you really can't get at it here at all, or voila, the extender. So I'm going to pull out this tube. This is the 1L6. This is a very rare tube here. And so what I have not been able to do all along is test the voltages being applied to this tube and to this tube to make sure the plate voltage is there and the like. Now I can do it, and that's what we're going to do as soon as I wash my hands again. Okay, so I've attached the clip lead here to the B- point in the chassis because I'm going to be using my VTVM meter here to do the tests. And we can't be clipping this to the chassis. It's got to go to B-. The radio is plugged into an isolation transformer. That's why I can get away with doing this kind of stuff. Okay. Here. Now I need to know each of these terminals here. Let me check into that. Okay, you can see I've got some of the schematic on the screen there showing the these two tubes. The 1L6, this one is the one that I have on the extender. What I'm hoping to do is just go around the pins, start with pin 1 and just go 1, 2, 3, 4, 5, 6 around. You can see these are not in order on the diagram here, but they supply voltage information everywhere, so we can read all these voltages, and they're all taken. Let's see what it says here. All voltages measured with VTVM between socket terminals and B-, which is what I'm doing. Voltages are DC and positive unless otherwise specified. Oh, that's right too. I keep forgetting the heaters are running on DC. All voltages are measured in broadcast band position 7 with stick loop or loop antenna disconnected. Oh, with stick loop or loop antenna disconnected and gang fully closed. Some sets, some sets. With stick loop or loop antenna disconnected. I guess that's maybe to silence, to make sure it's not picking up anything. That's probably what that's all about. Okay, we'll put this back there. Okay, so let's turn this guy on. Turn on my voltmeter. I think the first reading is an AC reading. I think I remember seeing pin 1 is 8.1, not AC. Jim, there's no AC. Wow, have I ever got a paradigm in my head? Holy smokes. DC, DC, all DC, DC. Okay, I guess I got to turn the radio on, don't I? So this is closed. And I think we're on the broadcast band. Probably doesn't matter. Okay, so the yellow would be showing, and now this should be showing. That would be okay. Looking at the pin numbering, it's reverse when you look at it from the top of a tube. It goes counterclockwise, 1, 2, 3, 4, and so on. Okay, we're good. We're good to go here. Oh, disconnect the antenna. Okay. And power on. There we are. Okay, I'll turn it down so we don't listen to it. It's doing what it always does. Annoying me. Okay, so we're on the 0 here. We're on DC plus. We're on 15 volts. We're going to go pin 1. Pin 1, we should see 3.1 volts. We're on the 15 volt scale, so we're seeing on this meter 2.9 volts. That's pretty darn close. And on the other side of the heater, well, we'll get to it. Let's just keep going. Pin number 2 is the plate. It should have 91 volts on it here. So it's a 150 volt scale. 90 is here. 2. And you see we're a little low. 108 volts on the supply. So again, this is supposed to be 91, and we actually have 78 volts. I didn't get out a piece of paper to make notes. Let's just keep going. So, but the thing is, the plate voltage is there. I was a little worried about that. Pin number 3, we should see 66 volts on the screen. And we're seeing very close to 60 volts, not 66. So the screen seems to be there, but the plate seems a little low. And the only thing different between them, no, they're quite different. The supplies are quite different. Next, pin 4, we should see minus 3 volts. Red with my okay, 5 volt full scale, negative voltage goes up screen, up scale. Pin number 4. 1, 2, 3, and 4. So we got a problem here. This is supposed to be minus 3 volts, but I'm reading plus the 5 volt scale plus about a half a volt. So I mean that's not good. That's not good at all. That's on the grid of a very rare tube. We have a positive grid voltage. Well, positive when read to B minus. Now, where's B minus in relation to this? Might really want to read. Well, that's interesting. Now, how would you read this? If you wanted to read to the cathode, you wanted to read the grid voltage to the cathode. If you wanted to do that, which we do normally, you get out a. You wouldn't want to use one of these meters, but get out just a multimeter and go cathode to grid. But look at this one. Which side of the cathode is the heater? Or the heater is the cathode. Which side would you put it on? Because there's a voltage difference, a DC voltage difference between like pin 1 and pin 7 on the 1L6. Well, we'll have to just accept their reading of minus 3 volts relative to B minus. It makes sense. But that's not the case here. Let's read it again. Positive voltage. Positive voltage. The 1.5 scale. You know, it's 0.35 volts. Same sort of thing here. So that's a problem. Could that be the cause. I don't know, how do you get it flipped around? How do you get it flipped around to be positive here? Well, maybe this capacitor. If we look up here, oh no, it goes into here, comes out here, goodness knows where. What's it doing? I don't know. So often a grid is attached to a previous plate. Oh, wait a second here. Wait a second. Jimmy. There's two signal grids in this tube. I haven't drank enough coffee yet. The -3 is on the oscillator grid. Long wave band. Did they? Yeah, oscillator strips, oscillator here. So oscillator, of course. Different radios do this differently, but many of them, the oscillators apply to grid 1, and the signal comes in on grid, I guess that would be 4. So this grid is at risk of going positive because of the positive voltage over here and the capacitor here blocking it. So there's a risk here of this going positive. Look, they actually show it positive. Positive to B minus. I think that's the key thing. This isn't the actual working voltage. The working voltage is between the grid and the cathode here. So I think as long as it reads this on the meter, we're okay, even though it's a little odd. This one still is weird. Pin 4. Okay, next pin is pin 5, which is the screen. 46 volts on the screen. Okay, let's see if that's true. 46 volts. 50 volt scale. 46 volts. Pin number 5. So 1, 2, 3, 4. This is 5. And you can see the good voltage there. It should be 46. It's actually 38. But it's there. And then we go pin 6. This one is the 2.4 volt guy. Yeah, 1.5 volt scale. Oh, just 1 second here. Okay, momentary interruption. Now, what happened to my my probe? Where did it go? Here it is, way over here. Okay, so we're just measuring number 5. No, we're on to number 6, I think. 6 is where we expect to find 2.4 volts, and I think I was finding something other than that. 1, 2, 3, 4, 5, 6. 2.4 volts, so it's positive. I'm on the 1.5 volt scale, so it's way off. This is way off. Oh, I'm sorry, I'm not on the 1.5 volt scale. I'll take that back. I'm on the 5 volt scale. It's just 2 volts, a little low again. So everything's just a little low in here. The whole radio is a little low, probably, right from the power supply. So the positive negative grid. Let's just take a look at that more closely on the schematic here. Okay, this guy right here. So I was thinking maybe this capacitor is somehow leaking something. That's the normal thing that disturbs a grid voltage, is a leaky capacitor, but this is all kind of other way around, sort of. You would want to find how, yeah, positive, eh? So this would be the oscillator. In this tube, 2 signals are being mixed: the oscillator signal and the signal coming in from the antenna. The 2 of them mix together and they generate some new frequencies. And one of them, if things are tuned a certain way, if you're tuned to a station, one of those will be 455 kilohertz to carry on through the radio, and all the rest will be rejected at this point. So piles of signals coming out of here, and this thing is like a sieve, only letting one thing through. Maybe sieve isn't quite the right word. Then, how does this get to be negative? Where do you get a negative voltage from? You know, in a radio, negative voltage comes from the rectification of the output of the IF. Well, the output's really, really low. Nothing to rectify. No negative voltage coming back from here. From here. See this AVC pointing that way? Almost all radios seem to have a 2.2 megohm resistor in this position here. So when you get on this side of the resistor, you're on grid circuits. What the heck is this? AVC, white wire. AVC. It's applied to the RFM. It doesn't seem to be applied here. Not that this has any impact, it's just things that are worth any impact on the current situation. It's just these are all important things to pick up and note as you come across them while you're doing this kind of stuff, you know, and just put it on the shelf. Now you know. Now what do I know? This tube is not controlled by AVC. So where do you get the negative voltage then? It can't be coming from anywhere down here. These are all positive voltages. This is a positive voltage. The only way you can make this negative is bring it in from here. How can you do that? This is a capacitor. Because it's an oscillator. Because it's an oscillator, when it oscillates, the grid ends up negative. I don't know if that's true or not, but how else? So there's a lot of trouble with knowing if an oscillator is working. In my case, I tend to use my SDR radio and try to pick it up as a radio signal. Because if you put instruments on here to try to measure this, you disturb the circuit and ruin the oscillator, and you won't get a reading. Well, you'll get a reading, but it won't mean anything. So could that be happening too? I'm putting my voltmeter on here and it's just throwing it right off. I don't know what to do about it. Don't know how it got there. Don't know where it came from. Don't know anything. We'll just put that. We'll just make a note of that. Everything else is just testing low, but there, it's all there. So we're going to go on to the next tube, the 1U4, and do the same thing. See what's going on with that one. Okay, let's do the same thing with the oscillator tube. U4. Now, I'm not going to have a shield on this. Probably won't present a problem, but if it does, we'll have to put a shield on it and then ground the shield back to the chassis. Okay, let's let this radio warm up while I wash my hands again. Okay, it's making the usual noise. Okay, so this tube, pin number 1, 1.8 volts on pin number 1. One's here. 1.8. We're on the so that's the 1.5 volt scale, so you can see it's a little low. It should be 1.8, but instead it's, so it just, again, just seems like everything is a little low. Pin number 2 is 70 volts. 70 volts on pin number 2. We're getting 60 volts here. Okay, pin number 3 should be, read the right one there, Jim. Pin number 3 should be 88 volts. Oddly enough, you have a higher voltage on the screen than on the plate. Pin number 3, that's not commonly done, but then again, there could be a reading thing, just the way the test is being done. So here we're reading 74. Let's be 88 and 70. We got 74 and 60. Well, about the same ratio, I guess. And pin number 4 doesn't appear. 5 is 1.8 volts on pin 5. Pin 5, 765. Why am I... Oh, pin 5, because pin 5 and pin 1 are the same. They're tied together. So we get the same thing. Not just under 1 point. It's about 1.4 instead of 1.8. And this is on the heater string. By the way, pin 7 should show 3.1. Pin 7 would be here. Go right over, yeah. This should be 3.1, 5 volt scale. So this is 2.2 as opposed to 3.1. That's quite a bit lower. I'm not sure what to make of that yet. Okay, and did I skip one? Didn't I skip one? Pin 6. 1.6 volts on pin 6. Pin 6 will be here. Should be 1.6, should be over the scale. This is a 1.5 scale. It should be over here. Instead it's here. That's about a 50% drop. And this is tied into the IF. This one's controlled by the ABC voltage too. So there could be something happening there with because of course the test results you're seeing on the schematic are when the radio is working 100% perfect. If it's not working 100% perfect, some things may be a little off. Not because of problems where you're measuring it, but because of other things going on, like the general low voltage all through the radio is probably a weakness in the power supply, and I would point to that 2500 ohm resistor or 2000 ohm resistor that gets hot and goes to 2500. And I'd also wonder about the rectifier that's in the radio here. So really the only real anomaly I just found is the positive voltage that should be reading negative. And you know I've done the tests. At least what we found out is the voltages are present. So these tubes are not dead. And again, we're getting this. Maybe the next thing to do is to go sharpen up the power supply. And maybe then, once the power supply is doing what it's supposed to do, check through all the heater voltages, although I think they're close enough. But I could check through those. And sooner or later we'll stumble on what's making this radio hum. That's my theory on that. That's going to be it for today. I started late, and it's another really hot day out there. I got some stuff to do. So thanks a lot for watching, and we'll just keep plugging along here. I'll see you on the next video.